Hello, today I will present my submission for CETA AS 496 Homework 3 Question 1. I have implemented a C program that compiles with six specific SEI, CERT, coding standards. First, let's compile the code using GCC. As you can see, it compiles cleanly without any errors or warnings. Now let's run the executable. I will enter a sample security log message and the base integer to spare. The program processes the data securely and terminates successfully. Now let's look at the source code. According to PRE31-C, we must avoid unsafe macros that can cause dangerous side effects during evaluation. Instead of using a standard macro, I securely implemented a static inline function here to guarantee safe parameter evaluation. Next, following DCL30-C, we must ensure objects have appropriate storage durations. Returning a pointer to a local stack variable causes undefined behavior. To prevent this, my function accepts a destination pointer from the caller scope to safely modify the buffer. Moving into the main function, exp33-c states that we must not read uninitialized memory, which could leak sensitive junk data. To comply, I have explicitly initialized all integer variables and character arrays to 0 right at start. For FIO30-C, we must exclude user inputs directly from format strings to avoid severe format string vulnerabilities. Instead of passing the raw user input buffer directly into printf, I securely use the strict %s format specifier. Moving into the main function, exp33-c states that we mustn't read uninitialized memory, which could leak sensitive junk data. To comply, I have explicitly initialized all integer variables and character arrays to 0 right at start. For FIO30-C, we must exclude user inputs directly from format strings to avoid severe format string vulnerabilities. Instead of passing the raw user input buffer directly into printf, I securely use the strict %s format specifier. All references being used should be clearly and correctly indicated in the reference part. To satisfy INT32-C, we must ensure that operations on signed integers do not result in an overflow. Before executing the multiplication, I implemented a precondition check against int _max to prevent any critical math exploits. Finally, FLP30-C forbids using floating point variables as loop counters due to accumulation and random errors which can cause unexpected infinite loops. To prevent this, I used a highly precise integer I as the loop counter and securely calculated the fractional steps inside the loop. By applying these 6 rules, the application mitigates common software vulnerabilities and guarantees robust execution. All rules are thoroughly documented in the source code comments as requested. Thank you for your time.